Math geometry lesson from Unit 1, Lesson 6, constructing parallel and perpendicular lines. So we'll get right to 6.2, which asks you to create a perpendicular line to M that goes through point C. I'm going to do this quickly since we'll do it in class as well, but here goes. The first thing I'm going to do is make a circle centered at point C, and it can really be any size circle as long as it crosses line M in two places. The reason for that is we're going to use those two intersection points next. Now, because I constructed this circle centered at C, CG and CH are both radii, which means that C is equidistant from both points G and points H, meaning it's the same distance away since the radius is constant within the circle. So if I want to construct a perpendicular line through point C, I at this point can actually construct the perpendicular bisector of segment GH, because C will be one of those points equidistant from both G and H along the perpendicular bisector. So if you forget how to create a perpendicular bisector, we just need two overlapping circles of the same size. I'm going to make mine centered at H going through point G and centered at G going through point H. But you could make them any size circles as long as they're the same size as each other and they're centered at points G and H and they overlap. So now at this point, what I can do is I can grab my intersection tool and I can mark both of the intersection points. They come out I and J. And when I draw this line here, I've created a perpendicular line through I and J, perpendicular to line M, and it also by definition passes through C, since the perpendicular bisector is the set of all points equidistant from the two endpoints, in this case G and H. All right, so that's the perpendicular line. Let's move on to the parallel one. Now, it might feel kind of counterintuitive, but to create a parallel line, we are going to first create a perpendicular line. So I'll do the exact same thing I did last time. Create the circle that intersects with line M, get those two endpoints, create the perpendicular bisector. That's going to get me a line perpendicular to M that passes through point C. Now, why in the world would I want to create a perpendicular line when it was asking me to create the line parallel to M? Well, if you create a line that's perpendicular to this new line, by default, it will be parallel to line M. So basically, I'm going to repeat that same process all over again. Now, just to kind of show you more simply what's happening, I'm going to hide all of the circles and points that I've made so far so that we just have the line M that was given to us, the point C that was given to us, and my new perpendicular line that we just did in the last problem. So what we're going to do now is we're going to try to kind of repeat the process where we're going to make a line perpendicular to this new line that I've added. And if you can visualize it, that will be parallel to line M. To make sure it goes through point C, we'll do the same starting move we did the last time. Make a circle, find the two intersection points with the line. Now this time C was on the line to begin with, so we're just finding two other endpoints along that line. And you actually could have used the first circle we used before, but I'm just making a smaller one so I can see this a little bit separately. And then if you kind of turn your head sideways, try to visualize repeating the process of making a perpendicular bisector of LM. So instead of making the circles like kind of side by side, they'll be stacked on top of each other like this. But that's that sideways perpendicular bisector to what we just did before. I find the two intersection points, and guess what? This line that goes through N and O also has to go through C. It kind of looks like it goes through K. That doesn't matter. You can move point K. K doesn't affect this. K was just the extra point when I drew my circle. So there we go. We now have a line that is perpendicular to, we could name this one LM, right? So NO is perpendicular to LM, and NO is parallel to line M. So hopefully that shows you how to tackle 6.2 and 6.3 from Unit 1, Lesson 6. Thanks so much.